All right, greetings, YouTube. Beautiful mind here. This is Mr. Pfeiffer. This is going to be our first official lecture for calculus for business. Yeah. So this is what spring 2021, and we're just going to go ahead and get started. Let me see how did that. Was I doing that before? Um, hmm. Oh, I know. I remember now. I was like, single page. I was like, yeah, that was the way I addressed that. Okay. Yeah, shaking off the cobwebs, like just getting back in the swing of things. Um, yeah, so I think we're ready to go. Ready to rock and roll. Let me see. It's kind of laggy though, and I don't know how to fix that. All right, well, and yeah, I don't really edit my videos. This is just full lectures. So let me try to get a timer going. So yeah, so what these are gonna do? This is we're gonna do like an asynchronous um, schedule where I'll do my best to make these lectures in advance. And then you watch them at your leisure, and we'll just use class time to like work problem sets. So I'll probably go through the homework during class time, and just try to have these available as far in advance as possible. So since our class time is like an hour and 15 minutes per session, my goal is to do about two of these presentations uh, per session, right? So if we meet, twice a week, I'm trying to get four of these out per week for you to use. So with that, I want the presentation to go for about 35 minutes each. Okay, so that's what I'm gonna target as best I can. Okay, so yeah, I do play Dragon Ball Z Dokkan Battle, and like one of the guys I follow, he just started streaming, and I was like, I want to get on the stream, even though I'm not gonna summon. Sorry, just totally being a geek and a nerd, like talking about my gaming. But I'm gonna go ahead and knock this out. So yeah, I'm watching the clock. I'm trying to limit this presentation to about 35 minutes. So we'll do the best we can to get through as many of these slides as possible. Uh, Whatever we don't finish here in this presentation, you can just ask me, and I make dedicated YouTube videos responding to like questions. So if you want to see something presented or mapped out, just let me know, and we'll make it happen. All right, so we're gonna these first couple of sections are kind of serve as a review. So we're going to start with chapter R, functions, graphs, and model with section R4, slopes and linear functions. So some objectives here are to find and interpret the slope of a line, graph equations of the form y equals c and x equals a, graph linear functions, find an equation of a line when the given slope and one output on the line, given one slope and 1 point on the line, and when given 2 points on the line, and then solve applied problems involving slope and linear functions. So we have some definitions here. It says the slope of a line containing the points P1 and P2, x1, y1, and x2, y2, respectively. Let's see, like this should work. Let's see, can I change that setting? I want the tail. hmm Yeah, it's kind of a lag. I don't know how to address that other than maybe like clear my computer. But anyway, so we have the slope of a line containing 2 points is given by this. The slope, which is going to be y2 minus y1 over x2 minus x1. That's going to be the change in the y value divided by the change in the x value. So you might remember slope as like rise over run. So that's essentially what's going on here. So in this example, we're asked to find the slope of the line containing these points. Okay. So let me see here. That should be good. Let me add this to fabric. Hmm, actually, can I just no delete that? I think that one's good. Okay. So slope, right? So one of my mentors from Morehouse when I was a student there, he would say every time you use the formula, write it down, right? So what's a good idea is to have a formula sheet, just one sheet in your notebook where you have a catalog of all formulas that we talk about. So the formula here is the slope formula. We've mentioned it once. Let's just say it one more time. So the slope is going to be rise over run, which is the change in y over change in x. So it's going to be y2 minus y1 over x2 minus x1, all right? So changing y over changing x, okay? And then often when I have 2 points, I just automatically go ahead and label those points. I just automatically go x1, y1, x2, y2. That's just for simplicity's sake, right? Okay. So then if we apply the corresponding coordinates into the corresponding points, so y2 is going to be 9 minus y1 is going to be 6 divided by x2, which is going to be negative 4 minus x1 is going to be negative 2. Okay. So then 9 minus 6 is 3 divided by double negative becomes what? Positive? Let's do this. So then negative 4 plus 2 is going to be what? Negative 2. So then the slope, see if this works. Okay. So the slope of the line between the 2 points should be negative 3 by 2, right? So that's us just working it out. And then I think we have a typed version that pretty much does the same thing. Okay. So as you make your way through these notes or these presentations, as you have questions, you have to write them down and just ask me during class time. So I know you might not get a chance to see this one before class, um, but just email me or ask me during class. And like again, I'm just gonna save class time for basically like working through the homework or and or answering questions or working through specific requested homework questions. Okay, let's keep it moving. So quick check, find the slope of the line containing these 2 points. Again, every time we use a formula, write it down. So again, slope, changing y over changing x, that's going to be y2 minus y1 over x2 minus x1. That constant repetition of writing it down ingrains it in your memory, right? That's how you learn. Math is all about pattern recognition, and the only way you pick up on the pattern, you got to do it a whole bunch of times, right? So then I usually go x1, y1, x2, y2, and then so y2 is going to be negative 4. Okay, let me do this real quick. So what's recommended whenever we're doing these substitutions is the following. So every time we're doing a substitution, replace each variable with a blank set of parentheses. That'll help us to keep track of the negatives, all right? So then y2 is negative 4, minus y1 is 3, x2 is 1, minus x1 is 2, right? So it wasn't too much of an issue with the negatives here, but you know that technique of the blank parentheses would have helped us in the previous one. So then negative 4 minus 3 is going to be negative 7 divided by 1 minus 2 is negative 1. A negative divided by a negative is a positive. Okay. So then we got a positive 7 there. So let's check it with the preloaded type version, and they get the same thing. Okay. I'm just watching the clock. I got another clock somewhere. Oh, I see it. 10 minutes. Okay. That's about right. So in this example, it asks us to graph this and decide whether the graph represents a function, and then what's the slope of the line. So we asked the graph y equals 4, right? So for this one, let's make a table. Just make a quick table. So we're gonna do x versus y. It says y equals 4. So what that means is that no matter what x value we choose, y is always 4, right? So for instance, when x is, let's say, negative 7, y is 4. When x is negative 2, y is 4. When x is 0, y is 4. When x is 1, y is 4. No matter what x value we choose, y is 4, right? So I just wanted you to see what I consider to be a simple way to graph something of that nature. So then it asks us to decide whether the graph represents a function and what is the slope of the line. I'm kind of tempted. Let me go ahead and just do the slope thing real quick since that's what we were already doing. Again, slope changing y over changing x, it's going to be y2 minus y1 over x2 x2 minus x1. That's going to be, I'm just going to choose 2 points. So I'm going to say this is my x1, x2, y1, y2. Right? I just chose 2 points. So then my y2, we're going to say 4 minus 4 over 1 minus 0. That's going to be 0 over 1. Okay, let me make this note. So if we say 0 over some number, this is okay. This is okay. So 0 over some number, this is going to be equal to 0. But if we said some number over 0, some number divided by 0, that's a KO. You want to knock that out. So some number divided by 0, that's going to be undefined. Okay. So 0 divided by some number, that's okay, so that's going to be equal to 0. But some number divided by 0, that's a KO. You want to knock that out, so that's going to be undefined, right? So is this the okay or is this the KO? This is the okay. So this slope should be 0. Okay. So now let's go back to the graph, right? So to plot these points, we made a table. We plot the points, and we should get the following, right? So no matter what x value we choose, y is always 4 in this case. So then the graph is just going to be this horizontal line that you see here. And then is this a function? Notice that it passes the vertical line test no matter where we draw a vertical line. It touches the graph once, so then it is a function. Every y corresponds to exactly 1x. And we said that the slope was 0. Okay. Let's see my clock. I guess I got one down there. I don't want to spend too much more time on this. So again, we'll do the best we can. We got about 15 minutes remaining here. Okay, so this one is similar to the last one. It says graph x equals -3. So we can use a similar logic. We can still make a table, x versus y. This one is saying no matter what y value we choose, x is always -3. So, like for instance, if y were, we could do y is -6, x is going to be -3. Y can be -2, x is going to be -3. Y could be 0, -3. We can do 1, -3, so on and so on. No matter what y value we choose, x is always going to be -3. Let's do the slope here as well, the same way we did the last one. So slope is going to be the change in y over change in x. It's going to be y2 minus y1 over x2 minus x1. If we label, I'm just going to choose the two points on the right. So this can be x1, x2, y1, and y2. So then if we plug those in, that's going to be 1 minus 0 divided by -3 minus -3. That's going to be 1 over 0. So is this the OK or is this the KO? This is actually an example of a KO. So then this one is going to be undefined. Undefined slope. Okay. So if we were to plot those points, -3, -6, -3, -2, we'll get a vertical line. Notice that this is not a function because this is an example of something that fails the vertical line test. Notice when we draw a vertical line, it touches the graph infinitely many times, which is more. It touches the graph more than once, so therefore it's not a function. And then the slope should be undefined. Okay. So quick check. We got x equals 4. So that means no matter what y value we choose, x is always 4. So we'll get a vertical line through x equals 4. Y equals -3. No matter what x value we choose, y is always -3. So we get a horizontal line through y equals -3. So now we have another definition. It says the graph of y equals c, or f of x equals c. A horizontal line is the graph of a function. Such a function is referred to as a constant function. So if we have y equals a number, we call that a constant function. The graph of x equals a is going to be a vertical line and does not represent a function. Okay. So the graph of a function given by y equals mx, or f of x equals mx, is going to be a straight line through the origin and the point 1 comma m. The constant m is called the slope of the line. Okay, that's fine. Here are a few examples. Here are various graphs of mx. Y equals mx for positive values of m, and here are various graphs of y equals mx for negative values of m, right? So like y equals, for instance, we got y equals 2 times x, y equals x, y equals 3x. These are just different variations of the graph y equals mx. For positive slope on the left, notice it has a positive slope. If we take one of these lines and as we trace it left to right, notice it goes up, right? On the right hand side, as we trace it left to right, notice it goes down because it has a negative slope. As we trace this from left to right, it goes up with a positive slope. So the variable y varies directly as x if there is some positive constant m such that y equals m times x. We also say y is directly proportional to x, right? So that's just saying that y is basically directly proportional. It's going to be this function here. When you see directly proportional, it's going to take on this form. So as we kind of work through examples and it says y varies directly as x, we also say that y is directly proportional to x is going to take on this form. Again, where m is a positive constant, okay? So in this example, it says the weight m in pounds of an object on the moon is directly proportional to the weight e of that object on Earth, right? So directly proportional, or y varies directly as x, so we can express one as a multiple of the other. Time. An astronaut who weighs 180 pounds on Earth will weigh 28 pounds on the moon. Find an equation of variation. An astronaut. Okay. So it says the weight m in pounds of the object on the moon is directly proportional to the weight of the object on Earth. So then we can express this: the weight on the moon is going to be equal to some positive constant m times their weight on Earth. So I'm kind of short on space here. Okay, 28.8 pounds on the moon. So then 28.8 pounds on the moon is going to be some m times their weight on Earth, which is 180 pounds on Earth, right? So then the constant of variation, if you divide both sides by 180, m is going to be equal to 28.8 divided by 180. Let me show you this. Let's see if I can pull this up real quick. Let's get rid of this one. Mm-hmm. Give me a moment, I'll be right back. Just realized I thought I downloaded this already. Oh no. Mm. Okay, I'll save that for later. I just have to remember to set it up. Let me see one other thing. Okay, I have to set it up later. I was trying to get my calculator going, but I had to reinstall Dropbox for that. I had to. Anyway, it's a long story. Let me see my time. I got about 15 minutes. Okay. Let me go 28.8 divided by 180. Yeah, let's just do this. Okay. 0.16. So then that gives us the weight on the moon is going to be 0.16 times their weight on the Earth. This is just the way that we set it up. Come on. Okay. So let's compare it to what we had typed. hmm So then the weight on the moon is going to be 0.16 times the weight on the Earth. Okay. Now you're lagging. Hmm. I think to fix that, what I usually have to do, let's do this real quick. Mm-hmm. Do a couple of things here. I'm going to get rid of that. Um, and then the other one is this. Get that one later. I'm coming, guys. I'm just updating something or trying to. And then here. Okay. Coming, guys. This one. Okay. Sorry. Mm-hmm. Where'd it go? All right. Sorry about that. Okay, I think we're back. Yeah. So it's just like knocking off some of the cobwebs, some different things. Okay. Um, let me see how much time. I'm gonna go for about another 5 minutes, and then I'll probably like wrap this one up. Okay, I think we got that one. Oh, and then to find the weight on the moon, uh, for astronaut who weighs 120 pounds on Earth. So then we use our model that we just created and just plug in the 120 for Earth, and it'll tell us the weight on the moon. Okay, so a linear function is given by this, y equals mx plus b, where m is going to be the slope and b is going to be the y-intercept. This is called the slope-intercept form of the equation. This is another one. If I were you, I would add to my formula sheet y equals mx plus b. Super Saiyan 4. Go, Jesus. All right, cool. Find the slope and the y-intercept of this graph. Okay. So something like this, I would just solve for y. I know we're kind of short on time. Let's see how much time. I'll go for like 5 minutes, okay. So the original, we have this 3x minus 6y minus 7 equals 0. So if we solve for y, I'm just going to add the 6y to both sides. So usually when I'm doing these, we're working on the left side versus the right side of the equal sign. So I'm going to add 6y to both sides. Negative 6y plus 6y, they add up to 0. So on the left, we're left with the 3x comes down and the negative 7 comes down. And there's the 6y there. Divide both sides by 6. I'm going to go ahead and switch these around so that the y is on the left. And again, I'm dividing both sides by 6. So then we'll get y equals 3 over 6x minus 7 over 6, which becomes y equals 1/2 x minus 7/6. Okay. So the slope is 1/2, and here let's answer the question that was asked. So then the slope is 1/2, and the y-intercept is a negative 7 by 6. So this is what the question was asking for. Let me see. Okay, so I got a few minutes, 1/2, and a negative. Okay, y-intercept. Okay, I like that they do the ordered pair for the y-intercept because sometimes they don't do that. Okay, find the equation in line with that slope containing that point. Okay. There's a couple of techniques. I'm just going to choose the one that I think is more simple here. I'm just going to start with the y equals mx plus b, right? We're given that the slope is 3, but then this point, it gives us this point, we got this x1, y1. Actually, we're also given this point, instead of doing it that way, we're given this point -1, -5, right? So let's just plug those in. So then y is -5, the slope is 3, x is -1. Only thing we don't know is b. So we could solve for b. If we add 3 to both sides, b equals, what is that, -2. So then the equation of the line is going to be y equals 3x minus 2. We get this result, and we need to check. All right. So when x is -1, -3 minus 2 is -5. And notice that the slope is -3. 3x minus 2, okay? So then this is a point slope form. This is another one that you could add to your list. I don't really use this one. The way I did it in the previous seems like it works every time. We're really supposed to use this one when we're given a point and a slope. But my students have shown me that you can actually just use the y equals mx plus b and it'll still work if I did it that way. I feel like you'll get more for less, right? You have to know less and you actually get more. You can use this one is fine. It works too. I just feel like you're more likely to make a mistake because it's more steps. Find the equation of a line with that slope containing that point. So you should get practice on the point slope form. I just want to do the slope intercept form again. And I'm watching the clock. We're almost out of time. So I'm just going to use this y equals mx plus b. If anybody wants to see a demo on the point slope form, just let me know and we can do that one as well. Containing that point. Okay, let's plug in the point. xy, so y is -5. The slope is 2 by 3. Our x in this case is -1. Only thing we don't know is b. So we add 2/3 to both sides. So then b is going to be -5 plus 2/3, 4 1/3. Let's get a common denominator. So then it's going to be what? 15, -15 over 3 plus 2 over 3, -13 over 3. So then we're going to get y equals the slope, which is 2 by 3 x minus 13 over 3. Okay, let me see it here. Let me see, what do we have left? Okay, let's see. We only have like a minute or so left. I'll do the best I can with this one. So, Rags Ltd., a clothing firm, has a fixed cost of $10,000 a year. These costs, such as rent, maintenance, and so on, must be paid no matter how much the company produces. To produce X units of a certain kind of suit, it costs $20 per suit per unit, in addition to the fixed cost. That is, the variable cost producing X of these suits is 20 X dollars. These are costs due to the amount produced and stem from items such as material, wages, fuel, and so on. So it says the total cost of producing X suits a year is given by the function, the variable cost plus the fixed cost. So 20 times each suit produced plus the fixed cost of $10,000. I graph the variable cost, the fixed cost, and the total cost. The variable cost is going to be 20 times X, okay, so that's going to be a diagonal line. Fixed cost is going to be y equals 10,000, so it's going to be a horizontal line through y equals 10,000. And then what's the total cost of producing 100 suits? Oh, and the total cost is going to be parallel to the variable cost, but then shifted up by 10,000. And then to produce 100 suits, you basically going to plug 100 into the formula. You see where the blue one crosses at the origin, and then the total cost crosses at 10,000 because we moved it up by 10,000 units, but it's parallel. Okay. Missed the 400 suits. Let's see. We're about out of time. I'm just trying to do a quick glance. I think you can make your way through this one. Okay. So we're going to kind of close out there because we're out of time. Just doing a quick scan. If anything important I need to say, and then we have a summary. Okay. So that's essentially it for section R4. I'm gonna like shut down and reboot everything up and go ahead and try to do the next section, and we'll just try to limit it to 35 minutes. Okay. If you have questions about anything, you have to write it down and either ask me during class time or email me, and we could schedule like other times. All right. Take care.